Good afternoon, dear students. Now let's discuss about 5-hydroxytryptamine. You know, 5-hydroxytryptamine is an autocoid. Actually, around 2 months over, and in the previous classes we were started discussing about autocoids. You know, the various autocoids. The various autocoids are histamine, 5-hydroxytryptamine, even prostaglandins, leukotrienes. They are the various autocoids, and in the last class we have completed histamine antagonist like H1 antagonist, H2 antagonist, everything we have discussed in the previous class. Previous means are, I hope in 2020 we have completed that. And now let's discuss about 5-hydroxytryptamine. 5-hydroxytryptamine is also called as serotonin. Okay. Now coming to the objectives of today's topic. After completing today's class, you should be able to know the physiological and pathophysiological actions of serotonin. Not only this physiological and pathophysiological actions, you should know the synthesis, storage and release, and also the receptors of 5-HT. So after completing today's class, you should be able to tell about the synthesis, storage, release, also the physiological and pathophysiological actions of serotonin. Now coming to this serotonin is a neurotransmitter also. It is an autocoid. Also it is a neurotransmitter. It is a monoamine neurotransmitter. Monoamine means it consists of a single amino group, and where it is present in the enterochromaffin cells of the stomach and intestine, and also the remaining is present in the platelets and brain. So where this 5-HT is present, 5-HT is present in the enterochromaffin cells of the stomach and intestine. The rest is present in the platelets and brain. Okay. And what's the role of this 5-HT? 5-HT is involved in migraine, also some affective disorders, psychosis, GI disorders and sleep. After the various conditions in which this 5-HT is having role is, it is having role in migraine, affective disorders, psychosis, GI disorders and sleep. I hope you understood. It is a monoamine neurotransmitter. Where it is present in the enterochromaffin cells of the stomach and intestine, and the remaining will be present in the platelets and brain, and it is having a role in migraine, affective disorders, psychosis, GI disorders and sleep. Okay. Coming to the synthesis, storage and destruction, you might be thinking why I have to study about the synthesis. You should know from where this 5-HT is synthesis, and from how it is metabolized. Even you used to get question like this: write the synthesis, storage and release of 5-HT. Okay, so it is synthesized from the amino acid tryptophan, and this tryptophan will be hydroxylated to produce 5-hydroxytryptophan with the help of the enzyme hydroxylase. From where this um, which is the starting material is the tryptophan. Tryptophan will be converted to 5-hydroxytryptophan with the help of the enzyme hydroxylase. This 5-hydroxytryptophan will be decarboxylated with the help of decarboxylase to produce 5-hydroxytryptophan. Okay, 5-HT. This 5-hydroxy tryptamine, 5-hydroxytryptophan will be converted to 5-hydroxytryptamine. 5-HT is 5-hydroxytryptamine. So it will be metabolized by monoamine oxidases to 5-hydroxy into acetic acid. It is synthesized from amino acid tryptophan. Hydroxylase enzyme will convert to 5-hydroxytryptophan. It will be decarboxylated to produce 5-hydroxytryptamine, and it will be metabolized by the monoamine oxidases to produce 5-hydroxy into acetic acid. Hope you're clear. Tryptophan converted to 5-hydroxytryptophan with the help of the enzyme hydroxylase. Again converted to 5-hydroxytryptamine with the help of decarboxylase enzyme, metabolized by monoamine oxidases to produce 5-hydroxy into acetic acid. Next, the reuptake. Synthesized serotonin will be reuptake by transporters. The transporter is SCRT transporter. SCRT is serotonin transporter serotonin transporter amine pump. It is an amine pump. So the transporter is the serotonin transporter. It's a sodium dependent transporter. And this transporter is inhibited by drugs like selective serotonin reuptake inhibitors and tricyclic antidepressants. So why we have discussed these drugs? We have discussed under antidepressants. This transporter, that is serotonin transporter, is inhibited by drugs like selective serotonin reuptake inhibitors and tricyclic antidepressants. It is taken up by serotonin transporter. It is an amine pump, and actually the serotonin will be stored in the vesicles, that is the VMAT, by an uptake process. The uptake will be taken place with the help of VMAT. VMAT is vesicular monoamine transporter. What is VMAT? Vesicular monoamine transporter. Coming to the receptors, the 5-HT receptors are divided up to 5-HT7. Okay, from 1 to 7. Again, this 5-HT1, we have 5-HT1A, 1B and 1D. And 5-HT2 also we have 5-HT2A, 2B and 2C. So this is the classification of receptors. 5-HT receptors. We are dividing from 5-HT1 to 5-HT7. Again, 5-HT1 we have 5-HT1A, 1B, 1D. 5-HT2 we have 5-HT2A, 2B and 2C. Coming to the pharmacological actions, I hope till we have discussed about the synthesis, then storage, then the receptors. Where it is stored, it is stored in the enterochrom. Where it is present, it is stored in the vesicles, mainly in the enterochromaffin cells. Then some transporter, SCRT transporter we have studied, and also VMAT transporter. It will be taking up the serotonin into the vesicles. Coming to the pharmacological actions, it is having action on the cardiovascular system, visceral smooth muscles, glands, nerve endings and adrenal medulla, respiration, platelets and central nervous system. Okay, what are the various system it is having its action? It is having action on the cardiovascular system. We know the cardiovascular system consists of arteries, heart and blood. It is having role in BP. Then it has action on the visceral smooth muscles, glands, nerve endings and adrenal medulla, respiration, platelets and CNS. Coming to its action on CBS, actually it is having a triphasic response. Triphasic response means if you are giving IV this 5-HT, you can have a 3-phase responses. Initially the BP will be falling, next BP will rise and then BP will fall. Okay, first BP will fall, then BP will rise and then BP will fall. The initial fall in BP is due to increase in the vagal activity. Vagal activity will be increased and it leads to fall in BP. After that BP will be rising. What's the reason for the rising is because of vasoconstriction, and again there will be fall in BP because of arteriolar dilatation. Okay. So this action on cardiovascular system, we can have a triphasic response in the BP, that is fall in BP initially occurs due to increased vagal activity. Then we can have we'll be having a rise in BP because of vasoconstriction of the larger vessels. Then there will be fall in BP due to arteriolar dilatation. In general, what we will be seeing is it will be constricting the larger vessels and dilates the arteries. Okay. Next is visceral smooth muscles. It is a stimulator of GIT. In the viscera smooth muscles, it's a stimulator of GIT. So in GIT, what will happen is increase in the GI motility and increase in the peristalsis. So diarrhea occurs. So GI motility will be increasing, peristalsis will be increasing, diarrhea occurs. In the heart, what it will do is it will be constricting the bronchi, but it is less potent than histamine. Okay. Visceral smooth muscles, it's a stimulator of GIT acting through the enteric plexus, increases GI motility, increases peristalsis and diarrhea occurs. and it constricts the bronchi. In the glands, what it will be doing is it will be inhibiting the gastric acid secretion and pepsin. Actually, gastric secretion, hydrochloric acid secretions and all will be decreased, but mucus production will be increased. So it is having also protective property. Next, in the nerve endings and adrenal medulla, the afferent nerve endings will be stimulated and it will be causing tingling, pricking sensation and pain. Okay, in the afferent nerve endings, by stimulating the afferent nerve, it will be causing tingling, pricking sensation and pain. Next is the respiration. Stimulate the respiration and there will be hyperventilation. But in large doses, it will be producing apnea. Okay. Next is platelets. There will be a change in the shape of the platelets by activating the 5-HT2A receptors. By activating the 5-HT2A receptors, there will be change in the shape of the platelets. In the CNS, if you are giving IV also, it does not produce any significant effects because it cannot cross the blood-brain barrier. Poor entry will be there. But if you are directly injecting into the brain, it produces sleepiness, change in body temperature, hunger, and variety of behavioral effects. And it is an inhibitory neurotransmitter. So coming to the pharmacological actions in the cardiovascular system, what we have discussed, triphasic response in BP, and large blood vessels will be constricted while it will be dilating the arteries. Next, in the visceral smooth muscles, what we discussed in the GIT, stimulated. So, peristaltic movement will be increased, diarrhea occur, but in case of bronchi, it will be constricting the bronchi, less potent than the histamine. Glands, it will be decreasing the acid secretions, but it will be increasing the mucus production in GIT. Then in the nerve endings, and it has also protective property. In the nerve endings and adrenal medulla, what we have studied, it causes tingling, pricking sensation and pain. Okay, tingling, pricking sensation and pain. In respiration, what will produce, it will be, it's a transient hyperventilation, but after that there will be apnea. Platelets, it will be producing a change in the shape of the platelet by acting on the 5-HT2A receptor. And finally, its action on CNS. In CNS, since it is a poor, it has a poor entry to blood-brain barrier, it has less effects on CNS, but still, if you're directly injecting into the brain, it will be producing some effects in the CNS, like sleepiness, change in body temperature, hunger, and behavioral effects, and it is an inhibitor neurotransmitter. Okay, now coming to the pathophysiological roles. The pathophysiological role, we know it's a neurotransmitter, it's a precursor of melatonin, it has neuroendocrine function, it has role in nausea and vomiting, migraine, hemostasis, Raynaud phenomena, ovarian angina, hypertension. It has role in intestinal motility. Let's see one by one. Neurotransmitter, we know it's a neurotransmitter and is distributed in the brain. What are the role of 5-HT? It has role in sleep, temperature regulation, thought, cognition, behavior, mood, appetite, vomiting, and pain perception. As a neurotransmitter, what the role of 5-HT as a neurotransmitter? As a neurotransmitter, the 5-HT control sleep, temperature, thought, cognition, behavior, mood, appetite, vomiting, and pain perception. Okay, so what's the role we have to study? It has various roles, like it control our sleep, it will be controlling our temperature, thoughts, cognition, behavior, mood, appetite, vomiting, and also the pain perception. Next, coming to the role as second is, it is a precursor of melatonin. Melatonin is secreted by the pineal gland, and It will be regulating the biological clock and maintain the circadian rhythm. You know what is this biological clock? In the morning we are waking up, we are doing your routine work, night we are going to sleep. Everything will be controlled by the melatonin. Actually the 5-HT is the precursor of melatonin and it will be controlling the biological clock. Next is neuroendocrine function. It will be controlling the hypothalamic neurons which secrete the anti-pituitary hormones. Hope you're clear with these 3 points. First, it acts as a neurotransmitter and it's distributed in brain and it will be controlling temperature, sleep, thought, cognition, behavior, mood, appetite, vomiting and pain perception. It's a precursor of melatonin and it will be controlling the biological clock. It's the neuroendocrine function. It will be responsible for secreting the anterior pituitary hormones. Next is nausea and vomiting. Actually 5-HT3 antagonists are useful to control vomiting induced by anti-cancer drugs and radiotherapy. We know while you are giving an anti-cancer drug, it will be inducing nausea, vomiting. That vomiting can be controlled. Severe vomiting will be there. That vomiting can be controlled by the 5-HT3 antagonist ondansetron. Next is migraine. We all know what is migraine. Migraine is a one-sided headache. There will be nausea, vomiting and vertigo. They will be very sensible to light and sound. And what's the reason is? The reason is due to an abnormality in the 5-HT transmission. So there will be dilation of the large cranial vessels. Because of dilation of the large cranial vessels, the blood flow will be reduced to the brain and it will be causing pain. That is because of this that occurs in migraine. And for this migraine we will be giving sumatriptan. Okay, sumatriptan, that is a 5-HT1B1D agonist. So it is having role in migraine. In migraine there will be initially vasodilatation. After that there will be vasoconstriction. It is proposed that 5-HT is having a role, and for that we will be giving this 5-HT1B1D agonist, that is sumatriptan. The prophylaxis is methotrexate, that will be discussing. We have separate topic to study this migraine. Okay, next is hemostasis. Hemostasis, here it will be accelerating platelet aggregation. Whenever there is an injury at that area, platelet aggregation and clot formation will be enhanced and maintain hemostasis. In Raynaud's phenomena, this 5-HT will be producing constriction of the large arteries. Next is variant angina. This 5-HT with the thromboxane A2 will be producing coronary spasm and variant angina. Okay. Next is hypertension. We know since it constricts the blood vessels, it can produce hypertension. And ketanserin is used to control the hypertension. Intestinal motility will be increased. Next is carcinoid syndrome. It is overproduction will be producing carcinoid tumors. Causes hypermotility of the bowel and bronchoconstriction. And these are the various actions. Hope you are clear. Neurotransmitter. Since it is a neurotransmitter, it will be controlling the thought, cognition, temperature, behavior, mood, appetite, vomiting, precursor of melatonin, control the biological clock. Neuroendocrine function. What is the neuroendocrine function? Secrete the anterior pituitary hormone. Nausea and vomiting induced by anti-cancer drugs can be prevented by giving this 5-HT3 antagonist ondansetron. Then migraine. Even this 5-HT has a role in migraine and that can be controlled with sumatriptan. Hemostasis, it will be maintaining the body hemostasis. Whenever there is an injury, it will be constricting the platelets. Next, the Raynaud's phenomena will be constricting the larger blood vessel. Variant angina, since it constricts the blood vessels, it may lead to angina. And in hypertension, it will be producing hypertension. And finally, what's this? Intestinal motility will be increased. carcinoid syndrome will be produced because of overproduction. It may produce tumors in the GIT. Because of tumors in GIT, there may be hypermotility and bronchoconstriction. Hope you're clear with the 5HT. What's the other name? What are the various receptors? Everything. Now next, synthesis, storage, pharmacological action, and also its physiological role. Everything we have discussed, and in the next class we will be studying the drugs. Okay, or the various drugs acting, the agonist and antagonist, or the various drugs controlling this levels, that we will be discussing in the next class. So be thorough with this 5T agonist, sorry, 5T actions, synthesis, everything. Okay, thank you.